I am looking at the self-directed learning and the learner profile, tracking the progress in digital and design technology and giving feedback through badges. The idea is that we need to develop a new Year 7 digital and design technology course, and we want this to so we need to develop the course for the students. We need to also work our way of tracking the feedback and tracking the progress and give feedback to the students. So we need to develop that process, and we need to be able to implement the project and then assess how well it worked. So first of all, the digital technologies and design technologies, we brainstormed this whole thing on the whiteboard. This is a new course for 2022. This has been redeveloped and redeveloped and redeveloped because every time we plan it, COVID is ruining everything for us, and we're not sure if we're going to be doing face-to-face education or if we're going to be doing, online learning or whatever. But regardless, we've kind of planned it out, and for the purpose of this topic, I'm just looking at the robotics section. This would obviously be expanded out to all 4 sections, or four topics, which would cover the 4 terms with 2 lessons per week for each student. There are 5 Year 7 classes at Pulteney Grammar, and I only teach one of these classes, and there's another teacher that teaches the other 4. He has never taught any technology before, so this is all brand new to him. He has no background in the subjects, so one of the reasons we did this is so that I can develop the course and then he can take over the material. And this way I can support what he's doing as well. So basically we're working on this as a competency-based education program. The good thing about this is the students developing mastery, which I'll go into a bit later. They also find it's meaningful. We're giving them timely support, and the idea is we actually want to extend the students to not just be teaching digital and design technology, but also a lot of the soft skills as well that we use, which it's at Pulteney is called the Pulteney DNA. The idea is also to take away from explicit teaching. It's very hard to do explicit teaching in digital technologies, because as soon as you start telling one student how to do something, half the other students get lost. Other half are going, well, this is way too easy for us. And so you want to be able to give them deliverable stuff. I use the flip learning method. I pre-record all my videos. Or we use Grok Learning is another system, which is an online learning system. So there's lots of different tools which we can use for the curriculum, but the idea is that we want to use the teacher as the assessor, the learning facilitator, and help them. The teacher then can help the students as they develop, so they can consume the content at their own pace. And anytime they need a hand or they want to demonstrate their competencies, that's when the teacher can come over. So we want to look at mastery. So one of the biggest problems we've got is students who are very good at IT or Digitech or whatever, are being held back by students or being held back by the curriculum when the curriculum moves forward at a very slow pace. Equally, some students really struggle with DT. They've never done any of this stuff before, and so they really need a lot of extra support. So we want a way of actually tracking their progress and allowing students to go beyond the subject material and beyond the year level. So that was one of the biggest issues we got. So the way we're going to do this is each class has got a different color, just for the sake of it. And in each class, there's about 20 to 24 students in each class. And we're grouping them, we're putting them in groups, but going across classes. Instead of putting them all in the same group, in a class, there are 24 groups in a single class. And those groups, so the actual collaboration comes from working across classes. So students can't sit back and allow someone else to do the work because there's no one else there. They have to do the work themselves, but they can actually get feedback from other people. So as you can see on the right hand side, I'm going old school with some stuff. I have a 192-page book for each group, and a pack of highlighters for each group. And what would happen is group 1, Aaron comes in from class 7.1. They come in, and that he's going to be working on his robotics kit. So I have 20 kits, 24 kits, which if I divided them between the classes meant you'd have 4 or 5 kits per class, and you'd have 5 students working on each robot. Then all the other robots will be put away. This way you can have one robot for one kid. That student uses that robot, does whatever they need to do, packs it up, writes in the book of what they've done. Then they grab the highlighter and highlight that section that they're writing. So and then gives feedback to the rest of the group. Okay, I've done this. I managed to get the robot to move forward and turn right. And then Adam comes in, has a look through the notes, goes, oh, we've got the robot to move forward and turn right. Okay, well, I can work out how to program that bit now. Okay, now I need to work out how to turn left and move and go up and down and so on. And then once the lesson's finished, he packs up his stuff. He does a quick note of how he's going and highlights it in orange and so on. So this grouping across classes is very different to anything we've done before. I have not found any other material where anyone's done it like this asynchronous grouping. So that's something new. We'll see how it goes. That's an extra side part to this project. But there is a lot of issues with doing this. Number one is you've got the students are working in the book. The good thing about this though is let's say I teach just class 7.1. Well, if there's a problem with the robots with Adam and Angela and Amy and Angus, if any of them have an issue, by the time it gets back to Aaron and he says, oh, look, Mr. Johnson, I've got an issue with this. The rest of my group are finding they can't get this to work. I can then help Aaron, which also helps everyone else in the other groups. So it means I can support all 5 classes just through my own class. All right. So setting up the groups, what we've done is I'm setting up in teams. This is an example of how I've done it in the past with my United Science. I don't know all the students in the class yet, so I can't put their names down. So these are just some random names. But what I would do is I'd have each group, so group 1 to group 24 down here with the students in here. The good thing about this is it's its own filing system. The students in that group have access to all the notes, photos, ideas, videos. They can video conference in that, so they can do everything within that group, within that little channel, and they can have all their own conversations. It's a way of sharing all that. So it's kind of the online collaboration. Also, I can jump in and see what they're doing very, very quickly, and it's all completely online. They still have the book, which stays with the robot, which tracks their progress, and then they can grab that and we can have one-to-one face-to-face conversations as well. So what I've done for this, the way I've set this up, this is different to what I've done in the past. We're looking at building a new learning platform, so experimenting with a lot of different types of things. So here I've done the self-directed learning, and I'm using VisPlan or VisiPlan, however you say it. The way this works, and this is actually embedded within Teams. Can I do this? I think I can do this. Yeah, okay, sorry. I need to go back to Teams. There we are. Okay, so here, this is my actual team and the actual plan. In here, you can see that I've got a different line or different tasks. So this is the robotics section, mission to Mars, test the rocket. So this is all the different tasks that they've got from here. And if I click on one of these, it actually comes up with exactly the task I want to do, when it's due, what the requirements are. They have to drive around this, and how it links back to digital systems. And the same for the rest of it. And now, so this is the current tasks. These are the ones that are active. The students can then assign who's going to work on what. So this is all about collaboration and working together as a team. I can go back to the matrix, which then this is all tagged, and my Gantt chart, which tracks the progress of these different things. All right, so now the problem that I've had with this though is, sorry, what I've just shown. One of the problems I've got with this is I've realized that this needs to be rejigged or redone, because instead of having mission to Mars, down on the farm, dual heists as different, they're called compatibilities in this program. I should have actually gone robotics and then put the mission to Mars in here, down on the farm and so on. So each of these lines should have been into this one. So down on the farm will be second, dual heist be in here, and then each of the, so this would be robotics term 1, this would be game design, this one will be the data networks and so on. But that was the learning process, which I realized after I've done it all. Regardless, once you've got the plan set up, you can then export this plan, and then I can go to each channel and import the plan for each student they collaborate with. The good thing is the students can see the progress of how they're going at any particular time, how the other students are faring, and so on, and they can, everything's laid out for them. So they've got access to everything right from the start. They're not being held back by anything. I still need to work out how to assess the progress of the students. You know, if one student ticks off that they've actually completed a section, can we go back and do the other students still have to complete it? Or do you go, well, that student completed it, the other students can move on to the next task, but they'll still keep their notes in their actual written book. So that's something that I need to overcome as we go. All right, so I've done this. So the other good thing is that when we're in here, and I can actually set this up and run this in Microsoft Planner. So when I go to Microsoft Planner, if I open this, all right, I'm just going to bring this across. When I go into Microsoft Planner, this is what the student sees, and so they actually see these as different, what they're called buckets of all the different tasks of what they have to do. So if I go back into here and open this, this will give them the notes. So that's the same as what we had in the Visi. Once again, this is how I worked out I've done it wrong, because I've got test the rocket, scan, and so on. So all of this is from the very first compatibility. Realistically, I should have had the different compatibilities or different term worth of tasks going down here. So be term 1, 2, 3, 4. As I said, that's something I have had to fix, or will have to fix as we go on. But the good thing is it then pulls it in, and it's a good way of tracking the progress and seeing how they go. Now, here we have, I'm tracking student progress. So once the students are doing their task, we're actually going to assess their competency in each task. And this is the overall competency from Excel, which I'm just doing in Excel at the moment, because we're going to be using a learning platform. I don't want to go too far down one pathway and then have to unpack it all. So we're keeping it in Excel for now. This is just an example of a year 6 piece of work. And I will, so here's, I've zoomed in. So I've actually gone through and worked out all the different things for digital technologies and design technologies. Down the left hand side, I have year 5, 6, 7, 8, 9. They start at 50 points and go up to 60 points. So at year 6, they should be registering as somewhere between a 60 and a 70. These are all their competency grades based on those. So a 60 to 70 is you're working within the standard for year 6, whether it's below or above or at standard. If they are well below standard, so basically this is your C, your B, and your D, an E would be below, so in the year below. If they're working well above standard, then they're going up to the year above. Now, so you can see here in this case these are shaded out because they won't actually be covered in year 6 or year 7. And equally we go and then go into the CARA general capabilities, so we're assessing against that. SACE is only year 11 and 12, but this is based on the Thrive learner profile, which is a new thing that SACE is doing and relates back to our learner profile. So we've removed that for up until year 10, and then it picks up in year 11, 12, and this is the Pulteney DNA. Now, from a student's point of view, these are just numbers. So what we've done is we've actually created these badges for them for each different competency, I guess. If we zoom in, you can see here, so this is year 6. This student's actually reached their at standard, so they've got a 67, and they've done that, so therefore they've got their competency, and they get their year 6 badge. So it's the same as the technologies and society, and all of CARA, the substandards or substrands, actually are the same across all year levels, and that's the same for just about every subject that I know of. If you break it down in science, it's physics, chemistry, biology, and psychology, and earth and space, and that's the same from reception all the way through to year 10. What you have to do for each of these changes across the years, but the substrands stay the same. So we've kept these icons for each substrand. You can see here a student's actually got 67, so they're working at a quite high level. Like this is a B, almost up into the well above standard, all that's up into next year. And then same as technologies and science for year 7, they're at 79, so they're almost up to the year 8 curriculum. These are grouped into colours because year 5 and 6 is a group thing for ACARA. You need to get your competencies between year 5 and 6, and same for 7 and 8. So that's why they're different colours. In other years, you could actually have different colours for each year. All right. And oops. So the idea is the students are trying to achieve their badges, right? So that as they're getting their competencies, they're getting these badges, and this would develop into a learner profile where they can actually see all the badges they've collected. Another example of the learner profile, which is based out of the work from the University of Melbourne, is this chrysanthemum model. So if we have a look here, you've got the disciplines for the different subject areas, general capabilities, and what they call know-how. These are also, as they go out through the different year levels, so, or different terms, however you want to put it. I have tried many different ways of doing this. I've tried doing it in 3D, I've tried doing it in Python, I've tried doing it in Excel, I've tried doing all different ways to actually draw this same configuration. I haven't been able to do it. The closest I've got is something like this, which is just, I guess in a sense, it's a spider plot. But this is the same information, and I'll just go out to my Excel spreadsheet so you can see it. So this is the actual spreadsheet with the work from the student. These are the badges we've created. And one thing I want to point out is you can see here, this student's actually got an 81, so they're worked up for authentic under Pulteney DNA. This student's actually doing quite well for their Pulteney DNA competencies, I guess you'd say. So this should actually be coloured in the next colour because they've actually got their next year level badge already, well, going up into that badge. I haven't got the badge, but they're working up into the next year level, which is great. However, for us, they're both as part of the same colour scheme, so I couldn't change colour. But this student's doing quite well. The student graph, the way I've done it is I've divided up in the same way. So this is your digital technology, so digital systems and so on. Then it goes into design technology. Over here is ACARA and then Pulteney DNA. Now I haven't included the SACE in this one because this is for year 6 and 7. The idea is that between these two rings, this is the year 6 area. So this student, the green line in the middle is working at standard. That's bang on the middle. This is the bottom end of the year 6 and the top end of the year 6. So this student's most of their stuff is, well, all their stuff is within the year 6 competency. Some of it's a little bit low, others are quite high, and then when they've gone on to year 7, they're all doing quite well. You can see some of them are even, well above standard. And so in this single snapshot, you can see exactly how the students are developing from one year to the next. I personally quite like the chrysanthemum model better, and I still need to work out how we're going to do that. The difference, that one thing I would like to do is I love how these are different colors as they're working out, working through different year levels. That's great, but I would like it so if you clicked on this, so this is, if we look at wherever the sciences say, if you clicked on this, then that would branch out and it will bloom out even, and you then have the different substands and substrands and how they're going within science, not just as a tally, but in all the different competencies for science. And that's something which we need to work on. All right, anticipated challenges. There is lots of challenges we're going to have along the way. We've got COVID, we've got infection, so those basic things, robots that don't work. We've got students who are off task. Students are not motivated to actually learn in an autonomous way. Whether my support or my other teacher who I'm working with can actually work the way through the material himself and actually support the students. I actually have lessons off so I can follow up with that and help the student out. Okay, factors that affect autonomous learning strategies. This is based on some of the work from Boyer and Bouchard and back to Boyer. Yeah, talked about cognitive algorithmic semiotics in economy. The easiest ones are semiotics is the way that we describe stuff online. We're transitioning from writing a book to writing online. The students are generally pretty good with this, and economy is also fairly good because the school's actually invested in this program. The connotative, which is whether the students are actually involved and want to participate in this task. and that motivation stuff. Now, what we want to do is do some testing at the start to work out what their self-efficacy is, their sorry, maybe getting ahead of myself here. Self-efficacy, entitlement, and motivation, basically. So we can actually find out whether they truly believe they're good at this subject and whether they believe they can do it. The algorithmic is the way we're programming the subject, so that's something which we're having to address at the moment. Here we're talking about connectivist learner. So basically, we're it's kind of a social constructivist or learning or social network learning, because they're learning across classes. So here we talk about self-efficacy, very important. Students who don't believe they can do it, not going to do very well. Students that self-selected. So here they've said that students that self-selected this have a lot better because they're already selected to do it. So students deciding to do this will be good. And we'll see this a lot better in Year 9, where the students can make their own choices of whether they do the subject or not. We are focusing more on measuring the learning for how they understand the work, rather than just going, yes, you've been here. So that's going to be important. And we're actually, the whole point of this is, it's an intentional learning process. The students actually want to learn, they want to be there, they want to formulate their own learning and how they're going to achieve that, and they can do that across the groups. So initial development plan, we've identified the curriculum, content, all the stuff, planned it all out. We're developing the unit plans and tweaking them as needed. We've done the digital badges, the know-how badges, the Cara badges, and so on. We created the challenges, so that needs to be readdressed as we go based on the student cohort we've got and the other teaching support. Some of the videos are already created and the content's ready to be delivered through Grok or through my own videos. We're packaging this. We have researched a new learning platform, so I can't do this until we've got the new learning platform. Be teaching it this year. That's just something we're going to be doing, and we're going to want to evaluate the success of the course by the end of the year. If it's successful, we're going to extend this. Want to extend it all the way down to reception and up to Year 12. All right, self-efficacy. So here we want to test the students, as we said, for self-efficacy and autonomous learning, academic entitlement, intrinsic motivation, extrinsic motivation, and amotivation, using these different questionnaires. This can also help us work out how to put them in groups, whether they're alphabetical groups or whatever, and also gives us baseline for whether we actually need it and whether they need more support with the project. So if a student's actually demonstrating they've got very low self-efficacy, very high academic entitlement, and a very low intrinsic motivation, then that student's going to need a lot of extra support just to get them through. Whereas some of the ones that seem to have less better self-efficacy and so on shouldn't need as much support. Also, it gives us, gives the opportunity to extend their soft skills, that Pulteney DNA. This is a big new development which only got launched at the end of 2021, so that's something which we want to work on, and this was a course which we thought we could embed it within. These are some of my references for what we've done, but overall, I'd just like to thank you for listening, and hopefully this all goes well.